In this video, we're going to complete the KutaSoftware Infinite PreAlgebra free worksheet Surface Area of Solids. Our directions for this worksheet are to find the surface area of each figure and round to the nearest tenth. I'll leave a link in the description below so you know how to access this free worksheet. Let's think about surface area. Surface area is the area of the overall surface of the figure. So if we were to take just the outside of the figure and add all of those areas up, that's what gives us surface area. So let's dive into number one and figure out what this is equal to. So notice in number one, we have a sphere. And a sphere has a very specific surface area formula, just like it has a specific volume formula. Because it has one continuous side, we're just going to calculate that entire area. So for a sphere, calculating surface area, the surface area, which I'll call SA, is equal to 4 times pi times r squared, where r, like usual, is that radius. So looking at our sphere in number one, it tells us not the radius, but it gives us the diameter as 4 meters. So if the measurement across, which is our diameter, is equal to 4 meters, we want half of that, which will be our radius, r. So taking the diameter of 4 meters and dividing it by 2, that's going to give us our radius of 2 meters. So now that we know our radius, we'll just plug that into our formula to find the overall surface area. So we're going to have 4 times pi times r, which is 2 meters, and that quantity squared. 2 meters squared is the same as 2 meters times 2 meters. So we're going to have 4 pi times, 2 meters squared. 2 squared is 4. Meters times meters, that's meters squared. And just to not confuse you, I want to point out the fact that this exponent is applied to both our value and our label. So you can see here, I've already distributed that in. We have 4 and meters squared. Again, this m is not a variable, it's a label, but the exponent is still applied to those labels. Another way we could think of this is as 4 pi times 2 meters times 2 meters. 2 times 2 is 4. Meters times meters is meters squared. But let's finish calculating out this problem. 4 times 4 is 16, so we have 16 times pi meters squared. Typing that in on a calculator and then rounding to the nearest tenth. 16 times pi, which is 3.1415, and so on, we're going to get approximately 50.3, and that's meters squared since it is an area. So 50.3 meters squared is our solution in number one. Let's move on to number two. Now, figures like number two, I believe, really capture the essence of surface area. Surface area is adding up the area of all the surfaces, or all those outside surfaces that make up our figure. So we have this side here, which is 4 centimeters by 5 centimeters. So we'll calculate that area. We'll add it to this area, which is another side. Don't forget this area here. And then all the other areas that are currently not visible. So let me use a different color for those. We'll have this back side here. And then we'll have this side here. And then lastly, this side here. So there's 1, 2, 3, 4, 5, 6 different sides on this figure. So we need to calculate the area of each of those 6 sides and add them together. But there's a shortcut for that. Think about it. This side here, that's 4 by 5, is in a couple other places. It's here, 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 and here. So it's in 1, 2, 3, 4 separate places. So we're going to do 4 centimeters times 5 centimeters, which is the area of one side, and then multiply that by the total of 4 sides that it's a part of. So now that we got those 4 sides, what are the other 2 sides? Well, the other 2 sides are 5 by 5 centimeters. We have one here, and then also one towards the back of this figure. So then we'll have 2 times our 5 centimeters times 5 centimeters. So the area of one side that occurs 4 separate times and the area of our other side that occurs twice makes up the 6 different sides of this figure. Now it's just a matter of calculating this out. So our surface area, which I'll call SA, is going to be 4 centimeters times 5 centimeters, which is 20 centimeters squared. That gets multiplied by the 4 sides, plus 5 centimeters times 5 centimeters is 25 centimeters squared, and that gets multiplied by the 2 sides it's a part of. So calculating this out, 20 centimeters squared times 4 is 80 centimeters squared, and 25 centimeters squared times 2 is 50 centimeters squared. Because we're adding these units, they stay the same. 80 plus 50 is 130. So this is 130 centimeters squared for number 2. Let's move on to our next problem. At number 3, we have the same kind of figure. This 3 by 6 side actually occurs 4 times. It occurs here, so that's 1. Then it occurs here, that would be 2. It occurs here, that's 3. And it also occurs here. That's 4 different sides that are 3 by 6. And what are our other 2 sides? Our other 2 sides are, well, these squares, these 6 by 6 sides. There's 1, and then here's the bottom 2. So let's go ahead and calculate this out. Again, we have 4 sides that are 6 meters times 3 meters, and then we're going to be adding that to our other 2 sides, which are both 6 meters times 6 meters. 6 times 3 is 18, so we have 4 times 18 meters squared, plus 2 times 6 is 36, so that's 36 meters squared. 4 times 18 is 72, so we have 72 meters squared, plus 2 times 36, which is 72 as well, so that's 72 meters squared. 72 plus 72 is 144. So we have 144 meters squared as our surface area for number 3. Let's move on to number 4. Now number 4 is a bit more difficult to think about. If you think about our surface area, we kind of have 2 separate sides. We have this bottom side, which is our base, but then we also have this other face, which wraps completely around as one full face. So we have 2 different sides that we need to somehow add together. We know how to calculate the area of a circle. That's just pi r squared. So pi r squared, the area of that circle, is going to be pi times 8 centimeters, that quantity squared. But we need to add this to the rest of our cone. How do we calculate that area? The rest of the area of that cone is computed by pi times r times L, where r is still our radius, but L is that slant length which is given to us as 17.9 centimeters. So entering that in, we're going to have pi times 8 centimeters times our slant length L of 17.9 centimeters. So again, the area of our base, which is a circle, is pi r squared, plus the area of the rest of our cone, which is pi times r times that slant length L. Adding this up, our total surface area is going to be equal to pi times 8 centimeters squared, that's 64 centimeters squared, multiply that by pi, plus 8 times 17.9 is 144 243.2, and that's centimeters squared as well, and also multiplied by pi. Now I can multiply this pi throughout to each of them, but because it's a part of both of them, same with our label, I'll just add the numbers together. So 64 plus 143.2 is going to be 207.2. We are still multiplying that by pi, and it has our label of centimeters squared. Again, I can do this because pi is a part or multiplied to both of those numbers. So I can add them together and then multiply through. Kind of like that distributive property. I can pull a pi out in front of each of those terms, which now it makes it a little bit easier to enter in on my calculator. I just have to type in 207.2 times pi. So this is going to give me approximately 650.9 centimeters squared for my surface area. Let's move on to our next problem. In number 5, just like in 2 and 3, we have a prism, except this time we have a triangular prism where 2 of the sides are triangles. The other sides are all rectangles. Let's calculate those rectangular sides first. You can see we have this side here, which is 4 inches by 5 inches. So I'll go ahead and multiply that out. My first side is 4 inches by 5 inches. I'm going to add that to my next side, which is 5 inches by 5 inches. But look, it's also connected to another side that's 5 inches by 5 inches. So I have 2 sides that are 5 by 5 inches. So I'll multiply 5 inches by 5 inches by 2. So that's 3 sides. And this has a total of 5 sides. So I did all the actual sides. I just need to do the top and bottom, or my bases, which is the area of triangles, but they're both the same exact triangle because they're the same base. So I'm going to add that to 2 times the area of one of those triangles, which will capture both areas. So the area of a triangle, remember, is 1/2 the base times the height. So we have 1/2 times our base, which is this length here of 5 inches, and then our height, which is this length here of 3.7 inches. Remember, the base and the height of a triangle are perpendicular, which is given away by this right angle here. So I'm going to have 1/2 times 5 inches times 3.7 inches. And if you confuse which one's your base versus which one's your height, it doesn't matter the order because of the multiplication. So let's go ahead and multiply this out. 4 times 5 is 20, so that's going to be 20 inches squared, plus 5 times 5 is 25. Multiply that by 2, that's going to give me 50 inches squared, and that gets added to, look, 2 times 1/2 actually cancels out to leave me with 1. So I just have 5 inches times that 3.7 inches, which is 18.5 inches squared. Now adding these all together, 20 plus 50 is 70. 70 plus 18.5 is going to give me 88.5 inches squared for my total surface area. Let's move on to number 6. Number 6, we're introducing another new figure, which we went over on our volume worksheet. This is a pyramid. And you can see for this pyramid, because our base is a square, which is 7 foot by 7 foot, that's one side. So multiplying that to get the area, 7 feet times 7 feet. And we're going to add that to, again, because it's a square, look at all the other 4 sides. All other 4 sides are the same exact triangle. So we're going to have 4 sides that are the same. We just have to calculate the area of one of those triangles, which is 1/2 the base times the height, where our base is that 7 feet and our height is 8.7. Again, base and height are perpendicular, so we know 7 and 8.5 are the base and height. and that same exact triangle occurs 4 separate times. Now we just do out this multiplication and add it together. 7 times 7 is 49, so this is 49 feet squared, plus there were 4 sides that were the same exact triangle, but let's simplify down. 4 times 1/2, because all of these are multiplied, order doesn't matter, I'll do this first. 4 times 1/2 is going to give us 2. So 2 times 7 times 8.7 is 121.8, and that's going to be feet squared, since we're multiplying feet by feet, and multiplying feet by feet on this side, we also get a feet squared. Summing this together, 121 plus 49 is 170, plus that 0.8, we're going to get 170.8 feet squared for our surface area of our pyramid in number 6. Let's move on to number 7. Number 7, again, we have a pyramid, except the base of this pyramid is a triangle itself. So let's go ahead and calculate the area of this base at the start, which I'll outline for us. We have 3 yards by 3 yards, and this other side is also 3 yards. So because that triangle is the same on each side, that means the remaining 3 sides, the side here, the side here, and the side on that back side, those are all the same triangle. So we're just going to calculate the area of our base and then add it to 3 times the area of one of those other sides, since all 3 other sides are the same. So let's calculate the area of our base at the start. It gives us the height of 2.6 yards and the base of 3 yards, because remember, those are perpendicular. So calculating the area of a triangle, that's 1/2 the base, which we calculated as 3 yards, times the height, which we said was 2.6 yards. And there's only one of those triangles for the base, which is this area here. However, we're going to add that to, there's 1, 2, 3 other triangles that are also the same exact area. So calculating the area of those triangles, just one of them, would be 1/2 times the base, which is, again, 3 yards, times the height, which our height is 2.2 yards. So the area of one of those other sides gets multiplied by 3 because those triangles occur 3 separate times. One here, drawing the base and height to kind of give you a different perspective, and then one here, again drawing the base and height for a different perspective of this figure. Now we're going to multiply this out and sum it up. So for the area of our base, we have 1/2 times 3 times 2.6, which is going to be 3.9 yards squared. And again, that's the area of our base. We're going to add that to 3 times the area of our other side, which is going to be 3 times 2.2 times that 1/2, which is 3.3 yards squared. So I didn't multiply this 3 yet because I wanted to show you that this area here, our bottom area, is 3.9 yards squared, and then one single other face of our pyramid is 3.3 yards squared, but there's 3 of those we have to account for. So now let's go ahead and multiply that 3 into our 3.3 yards. So our base is 3.9 yards squared, and all the other sides, those 3 other sides, are 9.9 yards squared when multiplied out. Adding this together and finishing off our calculations, 3.9 plus 9.9 is going to give us 13.8, and that's yards squared. That's our surface area of our pyramid for number 7. Let's move on to number 8. Number 8, we have another prism, and it's a triangular prism. So let's identify our bases. Our bases are going to be the same on each side. So we have one here, and we have one here. So 2 bases, each the same exact area. So that's going to be 2, calculating the area of those sides, times the area of, well, they're triangles. So that's going to be 1/2 times the base, which in this case is 3 meters, or we can even see the base is 4 meters. But remember, the multiplication is commutative, so it doesn't matter which one we use as the height or the base. So I'll go ahead and use 3 meters as the base, and that gets multiplied by our height of 4 meters. So this is calculating the area of one base. Multiplying that by 2 calculates the area of both. So now we just have 3 other sides to figure out. We have this side here, the front side, which happens to be 4 meters by 7 meters. So let's add the area of both our bases to this next side of 4 meters times 7 meters. So that takes care of one side. Now we got to look at our other side, which we can do the top next, which is this 7 by 3 rectangle. So we're going to add this to 7 meters times 3 meters, and then add that to, there's one more side, this back side, which is kind of hard to see, which is 7 meters by 5 meters. So adding that to 7 meters times 5 meters. Let's go ahead and calculate all of this out. Well, lucky enough for us, 2 cancels out with the 1/2, so we have 3 times 4 meters, which is 12 meters squared. We're going to add that to 4 times 7 meters, which is 28 meters squared. Add that to 7 times 3, which is 21 meters squared, and then add that to 7 times 5, which is 35 meters squared. Now, summing this all together, 12 plus 8 is going to give us 40. 40 plus 21 is going to give us 61, and 61 plus 35 is going to give us 96. So this is all equal to 96 meters squared, and that's the surface area of our figure in number 8. Let's move on to number 9. In number 9, we have a sphere. Do you remember that formula for the surface area? For a sphere, the surface area is equal to 4 pi r squared. But if you notice, this is very similar to number 1. In number 1, our diameter was 4 meters, whereas in number 9, it's 4 feet. So the only difference between the solution is the label. But let's work it out just in case to double check our solution in number 1. If we have a diameter of 4 feet, that means the radius r is half of that, which is going to be 2 feet. So the surface area is going to be equal to 4 times pi times 2 feet squared. That's going to be 4 times pi times 4 feet squared. 4 times 4 is 16, and 16 times pi is approximately 50.3. So this is 50.3 feet squared for number 9. Again, same solution as number 1, except our label is feet squared as opposed to meter squared. Let's move on to number 10. In number 10, we have a cone. Do you remember the formula that we used back up in number 4? The surface area, we have to calculate the one base, which is a circle, and then that gets multiplied by the surface area of the rest of the figure, which is calculated by pi times our radius times L, our slant length. So our surface area is going to be equal to pi r squared, the area of the base, plus pi r L, the area of the other remaining side. So our radius is given to us is 13 inches, so we have pi times 13 inches, that quantity squared, and we have pi times our radius of 13 inches times our slant length L, which is also given to us as 29.1 inches. So now it's just a matter of calculating this all out. 13 squared is 169. So we have 169 times pi inches squared plus 13 times 29.1 is 378.3 times pi inches squared. Again, because both have pi in it, I'm going to wait to multiply it out and just add my numbers at the start. So 169 plus 378.3 is going to be 547.3, and that's multiplied by pi, and our label is inches squared. So taking that answer and multiplying by pi, we're going to get approximately 1,719.4. So again, that's 1,719.4, and our label is inches squared. That's our solution in number 10. Let's move on to our next page, number 11. In number 11, you can see we have a rectangular prism. But unlike the rectangular prisms we've been working with, we have 3 different edge lengths. We have 18, 20, and 6 meters. But we know how many sides are there for this rectangular prism? There's 6 separate sides. So here we have a side that's 6 meters by 20 meters. Does it occur elsewhere on our figure? Yeah, directly opposite is the same exact side length, 6 times 20 meters. So we have 6 meters times 20 meters, which for the second page, just to save some space, I'm going to leave off my label until the end, but remember it is indeed meters squared because we're working with surface area. So I'm going to have my 6 times 20, but that occurs twice. So 6 times 20 gets multiplied by 2. That gets added to, let's look at another one of my sides. We have this side here, which is 18 by 6, and that occurs twice. So 18 times 6 times 2. So 2 times that's 6 times 18. And then lastly, I have this side of 18 by 20 that occurs twice. So again, that's 2 of those sides. So we're going to have 2 times the area of one of those sides, 18 times 20. Now it's just a matter of simplifying down. 2 times 6 times 20 is equal to 240. We'll add that to 2 times 6 times 18, which is equal to 216, and that gets added to 2 times 18 times 20, which is 720. Adding that together, 240 plus 216 plus 720 is 1,176. And remember, each of these had a label of meters, so that's meters squared. Let's move on to number 12. For number 12, we're working with a new figure that we haven't worked on for this worksheet, and that's a cylinder. So we need to calculate the area of the base, which is a circle, and that occurs twice. So we have 2 times pi r squared, and again, that's the area of one base. Multiply that by 2 to get the area of both of those bases. But then how do we calculate the rest of our figure? Well, think about it. The circumference is 2 pi r, and then we need to multiply that by h to get the total area, that circumference, all the way through h. So we're going to add that to 2 pi r h. And if you don't know what the circumference is, think back to if we had a figure like a square or a rectangle, the perimeter is just calculating the lengths of the outside. So for a circle, the circumference is just calculating that length of the outside, which is 2 pi r. Multiply that by h. So let's go ahead and plug everything in. We have 2 times pi times r squared, which r is 13, so that's 13 miles squared, which again, I'm just going to leave that unit off because we know surface area, it's going to ultimately be miles squared. If you need to leave that unit in to double check, feel free to do so. And then we're going to add that to 2 times pi times our radius of 13 miles, so 13 times h, which is 7 miles. So you can see again, 13 miles times 7 miles, that's going to result in a mile squared. Now let's go ahead and simplify this down. 13 squared is 169, and we multiply that by 2, we'll get 338. So this is 338 times pi for our first part, and then we're adding that to 2 times 13 times 7, which is 182, and that also gets multiplied by pi. Now because pi is in both those terms, I'll just pull it right on out in the front, and then add 338 plus 182 together. This is going to give me pi times 338 plus 182, which is 520. And when I calculate that out, pi times 520 is approximately 1,633.6. So 1,633.6, and that's miles squared. Now at the start of this formula, if you notice, we actually have a 2 pi r in each term. So we could simplify this formula down to 2 pi r times r plus h. Because if we pulled 2 pi r out of the first term, we only have 1 r remaining. And then if we pulled 2 pi r out of the second term, we only have h remaining. So just as we can pull that pi out here, we could have also pulled out a couple things in the beginning. So if you want to shorten the formula, use this, but I think it's easier to think, again, as surface areas, adding up the areas of all the sides. We have 2 bases, which are 2 times our pi r squared, and then we have that circumference multiplied by the height, which gives us the total area of that other side that wraps around. But again, 1,633.6 miles squared is our solution in number 12. For number 13, we have another cylinder. For the cylinder, we need to know both the radius and the height. The height is given to us as 13, and the radius is half of the diameter, which if the diameter is 20 meters, the radius is 10 meters. So for the area of my base, pi r squared, that's pi times 10 meters squared. But I have 2 of those. I have a circle on the bottom and a circle on the top. So that pi r squared gets multiplied by 2. And then I add that to my circumference of my circle, which creates the side if we were to extend that up. That's 2 pi r, which is 2 times pi times 10. And that gets multiplied by my height of 13. 10 squared is 100. 100 times 2 is 200. So I have 200 pi plus 10 times 13 is 130 times 2, that's 260, and multiply that by pi. 200 plus 260 is 460, and both of those were multiplied by pi. So it's just a matter of simplifying this down, doing it out on a calculator. 460 times pi is 1,445.1. So 1,445.1, what's our label? Surface area, so we're dealing with something squared, and it's meters on all our sides, so meters squared. Let's move on to number 14. 14, we have that pyramid where our triangle is the base. Again, like before, our base has all the same side length, 14, 14, and 14, which means that single base accounts for one side, and then the other 3 sides will all be the same. So we're going to calculate the area of our triangular base and then add it to 3 times the area of one of the other sides. So let's start with our base. For the area of a triangle, since we have a triangular base, that's 1/2 the base, which is 14, by the height, which is 12.1. The base and height of that triangle we're calculating the area of are perpendicular. So this is 1/2 times 14 times 12.1, and that will get added to 3 times the area of one of our other triangles, since they make up the other 3 sides. So the area is 1/2 the base of the triangle times the height of the triangle. The base of this triangle is 14, just like the base of our other triangle, but the height is 9. So that's 1/2 times 14 times 9. Let's go ahead and calculate this all out, simplifying down as we go along. 1/2 times 14 is 7. Multiply that by 12.1. I get 84.7. And then I'm adding that to 3 times 1/2 times 14 times 9, which is 189. 189 plus 84.7 is going to give me 273.7. So that's 273.7 meters squared, because meters was our label, squaring it because we're dealing with an area, 273.7 meters squared for number 14. Our figure in number 15 is a rectangular prism. We're going to calculate all the sides, but note for each of the edges we have 3 different lengths. So we're going to have 3 different sets of sides. First, we have the 10 by 7 side, which occurs twice. Then we have our 10 by 20 side, which occurs twice. And then we have our 20 by 7 side, which occurs twice. So let's calculate that out. We have 2 of our 10 by 7. Then we're adding that to 2 of our 10 by 20. And that gets added to 2 of our 20 by 7. Calculating the area of 3 separate sides, but each of those sides occur 2 times. 10 times 7 is 70, times 2 is 140, plus 10 times 20 is 200, times 2 is 400, plus 20 times 7 is 140, times 2 is 280. Adding this all up, 140 plus 400 is 540, plus 280 is going to give us 820. So this is equal to 820, but what's our label? Meters squared. So 820 meters squared is our solution in number 15. In number 16, you can see we have another prism, except this time 2 of those edges have the same side length. As opposed to having 3 pairs of sides, I'm going to have 1 pair of sides that are the same, and then the other 4 will be the same. So if you notice, I have a 16 by 16 here, and then only one other side that's a 16 by 16. So I have 2 sides that are 16 by 16, so 2 times 16 times 16, and that's going to be added to, look, I have a 16 by 20 here, I have a 16 by 20 here, here, and lastly here. So my 4 other sides are all 16 by 20. So then I have 4 sides that are all 16 by 20. Now that I've taken care of the area of each of my sides, 2 of them that are 16 times 16 and 4 of them that are 16 times 20, I just need to work out the math. So we have 16 times 16, which is 256. Multiply that by 2 to give us 512. And then we're going to add that to 16 times 20, which is 320. When multiplied by 4, gives us 1,280. Summing these together, that's 1,792. But we're not done yet, because what's our units? If each side length is centimeters, that's going to be centimeters squared for our surface area. So 1,792 centimeters squared. Now moving on to our last 4 problems, we're not given the picture, but we're told exactly what it is. So we have a cone with a diameter of 10 inches and a slant height of 13. Remember the surface area of the cone? That's our base, which is pi r squared. That's the area of our base, plus the area of the rest of the figure is pi times our slant height L. We're given our slant height of L, we just need to find R, which, if the diameter is 10, that means that R is equal to 10 divided by 2, which is 5. So we have pi times 5 squared plus pi times 5 times 13. 5 squared is 25, so we have 25 times pi plus 5 times 13 is 65, so that's 65 pi. 25 pi plus 65 pi is equal to 90 pi, and 90 times pi, when worked out on a calculator, is approximately 282.7. So this is 282.7, and what's our unit? Inches, so that's inches squared for the surface area. Let's move on to number 18. In number 18, it says that we have what kind of figure? A square prism, measuring 8 kilometers along each edge of the base, and it's 9 kilometers tall. So think about a square prism. If the base is a square, and we know we have 2 bases, that's 2 sides that are going to have an area of 8 by 8. So 2 sides have that area of 8 by 8. But what do the other sides have? Well, all of the other sides, if that base again is 8 by 8 and the height is all 9, those other 1, 2, 3, 4 sides, those 4 other sides that make up the sides of our figure, if we were to set it on its base, are all 8 by 9. So then we're going to add that to 4 times 8 times 9. 8 times 8 is 64. 2 times 64 is 128, and that's going to get added to 4 times 8 times 9, which is 288. Summing that together, we get 416, and our units for the side lengths were kilometers, so this is kilometers squared for the surface area. Let's move on to number 19. In number 19, it says that we have a sphere with a diameter of 20 yards. Remembering the surface area formula for sphere, that's the surface area equals 4 times pi times r squared. We're not given r, we're given our diameter d, but all we need to do is divide that by 2 to get r, which will be 10 yards. So we're going to have 4 times pi times 10 squared. 10 squared is 100. 100 times 4 is 400, so that's 400 pi. And when we multiply that out on our calculators, 400 times pi is approximately 1,256.6. So 1,256.6 yards squared for our surface area in number 19. Finally, on to our last problem, number 20. If you've stuck with me this far, go ahead and click that thumbs up button. But let's go ahead and finish this out. It tells us that we have a square pyramid. A square pyramid means that the base is a square, so the other 4 sides that shape that pyramid are all the same triangle. So if we know the base has a side of 9 yards, the area of the base is 9 times 9. So 9 yards times 9 yards gives us the area of our base. And we have to add that to 4 times the area of one of those triangles, since all the triangles of the remaining sides are the same area, and we have 4 of them. 4 times that area gives us the total area of the remaining sides. Now think about this. We know that the base of one of those triangular sides is 9 yards because that connects into our square. So we have 1/2 times our 9 yards, but what's the height of that? Well, it's the slant height of 12.8. So multiply that by 12.8 yards. And there we have it. This is going to give us the surface area of our square pyramid. 9 times 9 is 81, so we have 81 yards squared, plus 4 times 1/2 is 2. 2 times 9 is 18, and 18 times 12.8 gives us 230.4, and that's yards squared. So 81 yards squared plus 230.4 yards squared is going to give us 311.4 yards squared as our final surface area on this worksheet. If you have any questions at all, please feel free to leave them in the comments below. And as always, don't forget to like, subscribe, and share. All likes and subscriptions are greatly appreciated.